Alright, today you're going to be watching Nick and Mateo's physics demonstration. Happy to be here with you guys. We're going to talk about three things today. The first two, we're going to help explain the last one. The first one is voltage. What is voltage? Who cares about voltage? Well, we care about voltage because voltage is awesome. So voltage is defined on Wikipedia as the electrical potential difference. So it is potential energy, remember that, potential energy, between 2 points. So say 2 points on the wire. Now remember that traditionally protons and electrons attract each other just because of physics, and electrons repel each other. Now those electrons want to move, and therefore they have a potential energy to move, therefore they have a voltage. Now say you have a whole bunch of positive charge on one side, say one side of a battery maybe, and you have a single electron on another. Well, there's going to be a lot of pull on that electron, so there's a high voltage pulling that electron towards the positive charges. Say we have three weights. This is a metaphor. The weight on the left has no potential energy, therefore it has no voltage. Weight on the right has large potential energy, therefore it has high voltage. Think about these as charges in a wire. There's a lot of force pulling that rightmost one. Now say the same voltage can move different amounts of charges but different distances or at different speeds. It can move the large charge just a little ways or a small charge at a long distance. That's voltage. Second part of our series is electromagnetic fields, part 2. Now, electromagnetic fields are kind of hard to get your head around. They involve a lot of new words, but basically it is a physical field, and this is as defined on Wikipedia, produced by electrically charged objects. That's kind of hard to get your head around immediately. So this is basically just a combination of the electric field and the magnetic field produced by magnets and a moving current. An easy way to understand this is if you have electrons moving through a wire, so there's a voltage, potential energy pulling these electrons, a magnetic field will be produced around this wire. So that's basically the extent of electromagnetism. Now induction is the final part in our series, and it's kind of hard to understand. Induction is defined by Wikipedia, again, as the production of potential difference, which we now know is just voltage, and it's across a conductor when it is exposed to a varying magnetic field. Now this is kind of hard to understand at first, however, it'll get a lot easier. So here we have some stationary electrons, and say we have a whole bunch of magnets around these electrons. Now these magnets are electromagnets, so they're turning on and off very quickly, and you can think of them as moving if you want to. But basically, the magnets produce a magnetic field around these electrons, and that magnetic field, as long as it's moving, will cause the electrons to flow in a current with a voltage. So these magnets will actually induce, keyword, a voltage in those electrons. So the electrons will start moving, as you can see clearly. Now, why is this useful? Well, say you have two wires, and you have one wire with a current flowing. Now remember, it has to be an alternating current. This is known as AC, so the electrons are moving back and forth in alternating current, and this produces a magnetic field. But the magnetic field is alternating, so it's actually going to cause the electrons in the other wire to move. Now this is interesting because the number of coils in one wire and the number of coils in the other, if you're inducing electrical current in the other, the voltage will actually change. Now the current has to be changed as well, because the voltage times the current, this is key, voltage times amps, which is current, is always equal to the induced voltage times the induced current. Always. You can't get energy out of nowhere. And we're assuming that we're not losing any either. Now say we have 4 coils on one end and 2 on the other. What's really astounding is that you will get a direct proportional difference between the voltage on one and the voltage on another. So the voltage on the left, let's say, is 5, and since we have less coils on the other, it's going to change by a common ratio, which in this case is 4/2. And so 5 times 4/2 is equal to 10. Now the current has to die along with it. Say we have a whole bunch of coils on one end, say a few thousand, and just barely a few on the other. The voltage is going to increase by a huge amount while the amplitude dies. The current dies a little bit. this is kind of useful if you want to say build a Tesla coil, which is what we were going to do. So here's your average household computer transformer. Oh, that by the way is a transformer. Transforms the voltage. Now since computers use 12 volts, whereas your house gives out 140, you don't know what that. Now here is an awesome, badass Tesla coil transformer. This is if you say want 10,000 volts and want to transform your average household voltage into a 10,000 volt. That's all for now, guys. Hope you understand it pretty well. Thank you guys for watching.